My name is Adwan Bahrani, and I will be presenting to you our parallel computing project, which was a simple project of sending a lot of emails in parallel to lots of different um, email receivers or recipients. The main idea is that we want to personalize these emails and then effectively send them to like a very long list of emails. This could be used for marketing, this could be used for targeted advertisement, and the like. But the main problem is creating a big email sending program that will send emails in bulk to lots of recipients. The main challenge we had is that traditionally it's very hard to just personalize each email and send it one by one. And then when you use the BCC approach, it's also not efficient because you're not personalizing anything. You're sending one email to everyone, which lacks personalization, lacks the advertisement part of it, and makes it very hard to um, make sure that our emails are targeted and towards specific people to grab their attention. So we decided to solve that by creating a Python script. Now, the main goals of this script is to improve efficiency of sending these emails. So instead of sending them one by one, we need to try and send them in bulk. And also, we need to make sure that all of the emails are personalized. And of course, the solution has to be scalable. So if you have more CPUs, you will have better performance. And of course, it has to utilize the resources to their fullest extent. Now, when we were implementing this solution, we faced a very simple problem, right? The first iteration of our approach, we had one SMTP server connection, and all of the threads were trying to connect to that single connection. This created a problem because the SMTP server cannot handle many simultaneous connections at the same time. It needs to have different connections for each thread, which that's why the solution was to establish a separate connection for each thread, making it easier to organize the email sending process and make sure that the every thread gets the optimal resources necessary to do its task. Now, the results of our experimentation was actually very, very good. We achieved 4 times speed up using 4 CPUs in a MacBook Air, which means that each CPU sped up the process 1 time, which means that the process was using 100% CPU utilization, which means that this is also very, very scalable. The more CPUs you have, the faster your email sending will be. Now, to show you the comparison in terms of time, sequential execution was actually 34 seconds to send 8 emails, while when using parallel execution, it was 8.6 seconds, leading to 100% utilization of the CPUs. To conclude, this is the result of a very small scale testing, testing to very specific emails and very specific personalization. However, this demonstrated significant performance improvements using only 4 CPUs of my MacBook Air. This led to a 4 times speed up and 100% efficiency calculated from the active performance scores of the MacBook. Of course, the next steps will be large scale email sending with lots of CPUs using AWS servers or high efficiency computers with lots of CPUs. Thank you for watching. This was a brief on our project, and that would be the end of the recording. Thank you very much.